So we're going to continue on in this section 7 today. So we had been talking about inverses. And specifically what we had been talking about is how to predict if a function's inverse will be a function. Because last time we saw an example where we found the inverse of a function, and that inverse was also a function. And we saw an example where the inverse of a function was not a function, right? So we saw two situations, and we wanted to ask ourselves, was there a way to predict, or was there like necessary and sufficient conditions for, if I have a function with these properties, well, I know its inverse will always be a function. And we did find that last time. We found that if f of x is a bijection, then f inverse is a function. And remember what we meant by bijection. It had to have two properties. That the function must be one-to-one and also onto. Everybody vaguely kind of recall this from last time. I'm just kind of doing a little bit of recap because it's been at least 4 days, right? That was a long time. All right. So today, I want to go and talk a little bit more about how to find inverses, given the different forms that we might represent a function. And then, is there a way I can look at that function and be able to tell anything about its inverse before actually even finding the inverse? So I think we probably did last time enough practice doing that with the mapping diagrams, right? If I look back at my notes that I took, we did a bunch of examples of these different mapping diagrams, finding their inverses, and identifying if it was a function or not, and some of the properties of the initial function, and why or why not the inverse was or was not a function, right? Everybody kind of remember doing that last time? Okay. So you should feel okay with the mapping diagrams. Let's do some examples where we look at some different ways to represent a function, other than with a mapping diagram. So let's say that f is the set of ordered pairs. So before we go ahead and find the inverse, let's just take a quick check to see if this inverse will be a function or not. So to check this, I need to check to see if f of x is a bijection. So here, the onto part is kind of trivial because you're not given what did I use? wasn't the, I forget the terminology that I used here earlier. I want to be consistent, so just one quick second. We had a special name for the two kinds of domains. You guys remember talking about that? We had an implied domain and a relevant domain.
Yeah.
So in this case, since we're just talking about a set of ordered pairs or whatever, the implied domain is just going to be the relevant domain, which is just -2, 0, 1. In similarly with the range, it would be the range implied and relevant ranges would be 5, -3, and -1. So when you have a set of ordered pairs, unless they give you like some really specific information about that this is a function from this set to this other set, where you're told the domain and range might be something different than what's relevant to this set of ordered pairs you're given, we can just assume onto-ness. So we have onto. Is this one-to-one? Yes. How do you know? Or what are you looking for to tell that it's one-to-one? Okay. So basically, what we're looking for is that none of the y coordinates are repeated, right? So we notice that this is one-to-one. And we kind of gave a hand-wavy explanation as to why it was onto. So those things together tell us that f inverse is a function. Everybody okay with that? So if I want to actually find f inverse, does anybody remember how we find the inverse for a set of ordered pairs? You just swap the x's and y's. Yep. The word I like to use is transpose. That's a fancy math word for switching the two locations. And that's kind of all there is to one of these. If it's a set of ordered pairs, this should be pretty easy, right? Finding the inverse should be easy. Identifying domains and ranges, one-to-one and onto should be easy. Just as an aside, the only way that you would, if you were given a set of ordered pairs, is to claim, or if you were to claim it wasn't onto, is if you had like some extra information, like the following. Let's see. Oops. So if you were given a bunch of extra information about the relevant domain and range here, I'm sorry, the implied domain and range here. So like this information is the domain. That information is the range. You can see that there's a y value that's not used. Namely 7. You'd have to be given like a bunch of information like this to want to claim that a set of ordered pairs wasn't onto. I looked through the homework the other day. I don't believe this ever happens, but I thought since we talked, I gave that hand-wavy justification of why the other one was onto, I should at least make mention of what it would need to look like for you to have to claim it wasn't. And what you'd need is it literally for them to tell you the domain and range and see that there was something in the range that wasn't used. Everybody feel okay about sets of ordered pairs? This shouldn't have been much different than the mapping diagrams, right? Okay. So let's say that instead we're given a graph. So let's first determine if this is like one-to-one and onto. Sam, you're shaking your head. What do you see here? It's good. It's not one-to-one. And how could you tell that? Great. So, for example, if I take this y coordinate here, it's definitely used twice, right? So, oftentimes we can check to see if a function is one-to-one by doing what's called a horizontal line test. And from this, the fact that f of x is not one-to-one, we can say that f inverse is not a function. Excuse me. I apologize to all the video watchers out there when you get to that part. Yeah, you're going to blow your speakers out if you have it too loud. Everybody okay with that idea? Let's say, though, we actually want to draw the inverse. Well, one way we can do that is we can just kind of find some points on this parabola and use what we know about sets of ordered pairs and then use the new ordered pairs in our inverse to draw our graph. How many points should we pick from a parabola if we're going to do this? At least 3. Any requirements on those 3? I mean, could I pick these 3? Yeah, so Miguel says I need to use the vertex. Okay. Any other requirements?
One on each side.
Probably one on each side, yeah. So, I don't know, like, I'll just kind of pick 2 other random ones. Do they need to have anything special about them? Not really, right? So let's say I read off from the graph that maybe, oops, that these were the coordinates for these. Now, it's conceivable those could be given to you in the problem. It could be just that I read them off the graph. Everybody's okay with that? So, starting from the left to the right, so negative 2, 5 becomes 5, negative 2. Zero, negative 3 becomes negative 3, 0. And then 1, negative 1 becomes negative 1, 1. Everybody's okay there? And then I can just use this to kind of draw the rest of my picture. Everybody's okay there? And again, notice that f inverse is definitely not a function. That would fail a vertical line test. Everybody can see that? If you're to describe verbally what happened changing the picture for f of x into the picture for f inverse, How might we describe what happened there? How that picture changed? It flopped. So that's not a terrible description because there's a reflection happening. The reflection is across this line y equals x. So for example, if I reflect this point across that line, it would be over here. Its new location would be 5, -2. Or if I reflected this point over to here, that's now the point -3, 0, etc., etc. Do you guys kind of see that visually? Does that make sense to what I did there? Notice that every time I drew one of these reflections lines, those are perpendicular to that axis that we're reflecting across. Can we see that visually, what's happening there? Sometimes that's difficult to kind of see. Any questions about drawing the inverse of a graph? Hopefully that's reasonably clear. What if we're given f of x as an equation? That was the third way that we talked about that we could represent a function, right? We can have sets of ordered pairs, mapping diagrams, graphs, and then we can also have a function written as an equation. So let's say our function is written as f of x equals 3x minus 7. Does anybody remember how we find the inverse for f of x? I heard lots of things. Sydney, you said something, right? Good. Yeah. Get at the x by itself, and then swap x and y. I'm going to put in a step 0. Just replace f of x with y. That was probably pretty obvious. Most of us wouldn't have hesitated if I just did that without saying that I was going to do that, but I'll put that in as step 0. Some of you might remember swapping the x's and y's first before getting the y by itself. That's fine if you want to do it that way. There's small instances where if you're dealing with a restricted domain, that makes the domain restriction makes less sense if you do the swapping of variables before you solve, which is why I like to do it in the order that I'm describing here. But for the most part, it's probably fine to swap variables first before isolating. So if you're used to doing it that way, that's fine. No big deal. Okay, so let's go ahead and do our example here. So I've replaced it, the f of x with a y. Now we'll solve for x. So I'm going to add 7 to both sides. And then divide both sides by 3. And I've isolated that x variable. And then my last step would be to swap my variables. So I've just traded my x's and y's. Everywhere there's an x, I wrote a y, and everywhere there was a y, I wrote an x. So I'd say then f inverse is y equals x plus 7 over 3. And certainly if you wrote this as like x over 3 plus 7 over 3, that's fine too. If your instinct would have been to write it that way, no big deal. Doesn't matter to me. 6 and 1/2 dozen the other. They're both equally correct. Does that look familiar to you guys? So we're claiming that these two things are inverses. How would I go about proving that, though? What could we do to check to make sure that we actually did that correctly? Okay, you could graph and look to see if they look like reflections. That's not unreasonable. What if they were just really, really close, but not exactly reflections? Like looking at the graph has got a little bit of fudge factor in there, right? It could be really difficult to tell if they are exactly reflections or just really, really close. Okay, so Miguel's saying, well, I could check numerically to see if the xy coordinates are transposed. Can you check that for all the xy coordinates, though? Yeah, and by a long time you mean you'd never finish, right? Again, these are all excellent ideas you guys have had. These are exactly the kind of things that you should think of initially. There's one thing that we're forgetting about. How did we define an inverse a day or two, or a lesson or two ago? Does anybody remember that? Let's go back and look. So I can't remember if it was the 28th or the 27th. Oh, it would have been the 28th. We have that f and g are inverses, provided that f compose g of x equals g compose f of x, which is equal to x. So this is the best way, and really the most efficient way to prove that these two things are inverses. So if I want to verify that the things, or that the two functions I found are inverses, this is the way to go about it. So let's check that real quick here. So I'm going to need to do two things. I'm going to need to do f of f inverse of x, and I'm going to have to do f inverse of f of x. And what should I get for each of these two compositions? X is what I need to get to kind of verify this. Okay. Well, I know from my definition of composition that f compose f inverse of x is just f of x, or f of f inverse of x, excuse me. So I'll just replace f inverse with its expression. And then to do the composition, I'm going to rewrite f, and everywhere where there's an x, I'm going to put an empty set of parentheses. And inside that set of parentheses is going to be f inverse. And now I can simplify. So the times 3 and dividing by 3 cancel each other out. Bless you. Bless you again. You're welcome, you're welcome. And the plus 7 and the minus 7 cancel each other out. And I'm left with just x. Everybody agree with that? Let's see the other direction, because we're only halfway through. Again, I'm going to be following the exact same procedure, but instead of plugging in f inverse into f, I'm going to be plugging f into f inverse. But I'm going to go about this in the exact same way. And again, I see that that works. So I can certainly say that these two functions are inverses. Everybody agree with that? Good. Let's do another example that's a little bit more complicated algebraically. Because this one was fairly straightforward. You're just dealing with a linear function. So all the algebra involved in the rearranging and symbol pushing was pretty straightforward. There was nothing terribly tricky about this. Let's look at some other examples that are a little bit trickier. Sound good to you guys? Okay. So let's say that I have f of x equals 2x plus 5 over 5x minus 8. And we want to find the inverse for this. So just like before, I'll just start by replacing the f of x with the y equals. And then what do you suppose we should do next? Multiply by... Okay, multiply both sides by the denominator. Also equivalent to saying that, you could say cross multiply is doing the same thing, right? Really what you have here is a proportion, so you could cross multiply. Either way, you're doing the same thing, so no big deal how you want to reference that, what verb you'd like to use. So we multiply both sides by the denominator, that's the 5x minus 8. I get y times 5x minus 8, and then 2x plus 5. Is everybody okay with that part? Okay, what should I do next? Distribute, I heard somebody say, so we'll distribute that y. Okay, I like that idea. Now what? Again, what are we trying to do here on this step? Yeah, we're getting the x by itself, right? Notice we have x's in two locations right now, so that's a little bit odd. What do you think we should do to remedy that? Well, if we want to get x by itself, it probably stands to reason if we get x's on one side of the equation and the non-x things on the other side of the equation, that's probably a decent idea, at least to start with. Even if we're not quite sure how to get those x's into one location, I can at least get them onto one side, right? Is everybody okay with that reasoning? So I'm going to subtract 2x over and add 8y over. How about now? Any ideas now? I wouldn't do any dividing yet. There's an easier algebraic solution to what we're doing here than trying to do any dividing. Kayla? Yeah, that's an excellent idea. So notice on the left-hand side, both of the terms involve an x. So I can factor an x out. And now, rather than having x's in two locations, I have just one x now, correct? So now it's time to divide. Here we should divide by, the 5y minus 2. And things should look quite a bit nicer, right? And if we swap our x's and y's, we can say that f inverse is 8x plus 5 over 5x minus 2. So there's a situation where finding that inverse became a little bit algebraically tricky, right? The solution to doing this, or to getting the x by itself, wasn't super obvious, but I'm sure you've seen it before, and now that you're kind of refreshed about this trick, I'd assume that in the near future, if you see this again, you'd be able to handle that, right? Wasn't absurdly tricky. Let's now check to verify that these are inverses. So again, these I'm just going to recopy down my f inverse because at least on my sheet of paper that you could see they were very far apart. So I don't know that I could have gotten them on the screen both at the same time. So I just rewrote them here at the top. So I need to do two things. I need to do f of f inverse. And I also need to do f inverse of f. Everybody's okay with that plan? Okay. So, first thing I'll do is replace f inverse with the algebraic expression for f inverse. Then I'm going to rewrite f of x, except everywhere where there's an x, I'm going to leave an empty set of parentheses. And in that empty set of parentheses, I'm going to write my expression for f inverse. That gives us this nasty looking thing. Does anybody remember from your Algebra 3-4 class the name we gave to these nasty looking things here? It was two words. The initials are CF. You're close. It's a complex fraction, was the term that we gave this, where we had fractions inside of fractions. And this can be kind of a simplification nightmare. Looking at this, there's a lot of common denominators you might have to make, and then you have to divide fractions, and there's potentially a lot of steps here. I'd like to show you a shortcut, a nice little trick that we can use to turn this complex fraction into just a single fraction. What I'm going to do is I'm going to multiply by 1. But not just any 1. The way I'm going to write that number 1 is I'm going to look at all of the denominators, and I'm going to use the least common multiple of those denominators as my number 1. So in this case, there's only one denominator. It's 5x minus 2. So I'm just going to multiply the top and bottom of this fraction by 5x minus 2. So that's still multiplying by 1, so it doesn't change the value of anything. It's okay to do that. When I multiply to the first part, the 5x minus 2 in the denominator cancels the 5x minus 2 I'm multiplying in, and I'm left with just 2 times 8x plus 5. I also have to multiply it to the plus 5. So I'm going to get plus 5 times 5x minus 2. Everybody okay there? I'm going to do the same thing in the denominator, but I'm going to skip drawing the lines and just write the results here. Everybody's happy so far? And now we'll just do some distributing and some simplifying. So let's see, 16x plus 10 plus 25x minus 10 over 25x minus 25x minus 10 minus 40x plus 16. Did I make a mistake here? Right, this is supposed to be 8x plus 5 there also. Thank you. Why were you holding out on us if you saw that mistake right away? You need to be louder and more aggressive. If you see us, Mr. Kulik, write down stuff that's wrong, by gum, don't sit on that. That's more like it. At least I knew that I wasn't getting, there was something wrong there. I didn't go any further. Thank you, Lindsay. Everybody see what we did there? I just copied the wrong thing down like a dummy. Something, you know, like people make mistakes. Happened to me. All right, let's combine some like terms now. Those cancel out, and then those cancel out. And I'm left with, nope, try again, stupid. That'd be 41x over 41, which is just x. You guys try the other half right now. I'm tired of making mistakes in front of you guys. You guys can make mistakes in front of yourselves. We'll run through it here. Maybe we won't. There's only 5 minutes left in class. It might take you 5 minutes to do this. There's a little bit to do. But you know what the answer's supposed to be, right? Yeah. So that's nice. At least like, oh, you know if you're doing something wrong. But it's remarkably similar to the previous one, just with... You want me to scroll back up? Would that be helpful? That way you can get F and F inverse both on the same page. And the previous work. skipped some intermediate steps there for you guys, but those are the key ones. So I did add some homework assignment to the class page for next week or next time. We'll still be in this section a bit more